Welcome to the JuniorDev Canberra event. We are fully online for now, so just grab some snacks, relax, and enjoy the stream.
We would like to begin by acknowledging and celebrating the Ngunnawal and Ngambri peoples on whose land we meet and work. We wish to acknowledge their culture and the contribution they make to this region, and we pay our respects to their elders past, present, and future.
During the event, if you have any questions, please use the Slido link to post your questions, and our speakers will be happy to answer the questions at the end of their talk.
Today, we'll have Sherbaz Hashmi as our speaker for the Tech Talk tonight about Geospatial Information System. Sherbaz is the student doing a dual degree in Environmental Sustainability and Software Engineering at the ANU. He has received several awards from tech events and also started his own tech company focusing on developing human-centric systems. Tonight, his talk will dive into software architecture and also the system design behind the JS application with real-life examples.
Hi everyone, welcome to my talk on geospatial information systems for developers. So this talk is more oriented towards a general overview, so an introduction to what GIS is, common architecture from a development perspective, and a few case studies of using geospatial information systems. Before we get into it, I think it's worth introducing myself. So my name is Sherbaz Hashmi. I'm a co-founder at a company called Voltec. I've worked in the GIS sector for a while now, building out projects in the utilities, construction sectors, and also the federal government departments, a few of them. I've also won a couple of professional accolades within GIS, such as being the team lead of GeoHack 2019, which was an international hackathon hosted within the ACT. I've also won the ESRI Young Scholar of the Year in 2019, which was another geospatial award for Australia. And I also partook in the Innovation ACT, and my team won the grant in 2016. So I'm going to try to give you a general idea of what GIS is based on my experience. Cool. So what is GIS? That's a very big question. One good way of thinking about it is geospatial information systems are usually these complex systems and frameworks for data collection, management, and visualization within a geospatial context. So we can think about data collection as pulling data from either users or like satellite imagery, which we'll get into. We can think of data analysis along the, I guess, conventional statistical analysis route, but also applying geospatial elements to that, such as heat maps and clustering. But we'll also get into that a little. And we can also think about this with data visualization and interaction. And that's kind of where this human-computer interface paradigm comes in as developers, where we can build things like web applications, mobile and desktop applications to interface with these geospatial information systems. So I hope that gives you a bit of context as to what GIS is. Feel free to share any questions in the stream chat. I don't have it. I'm sure they'll get to me soon, okay? So let's start off. So before we get into the GIS part, I'd like to introduce this paradigm of open source versus commercial GIS. Some call it a war zone. If you go to any GIS forum or subreddit, there will often be two very distinct groups of people. One strongly rooting for a commercial solution, typically ESRI, and others definitely going for an open source solution, such as QGIS, GeoServer, Leaflet. They all have their own roles within the open source ecosystem. What I'm about to go through in this presentation will mostly have been built with ESRI, just because that's what I'm familiar with. But everything can be reproduced with these open source frameworks. I guess there are advantages to both. The commercial solutions are scalable, they're software as a service, they're enterprise ready, and they're not just aimed at developers. There's like this massive ecosystem almost. Whereas open source solutions, they're more specialized a lot more of the time, and they're usually less supported, but they give you options. So as developers, you might be more interested in the open source solutions. So cool. I think we're having technical difficulties. Give me one sec. Okay. So yeah, just continuing back to where we were, satellite imagery. So we can use satellite. This is the old school paradigm of data collection in GIS. We have different types of satellites orbiting the Earth, and you can usually take that imagery and do some pretty cool stuff with it. So you can analyze it. It's usually called raster imagery. You also have field data collection, as in you have a surveyor go out into the field and collect different types of measurement points and associate imagery. Photographic, as in just the pixels from a camera. They can get very high resolution these days. And you can also get LiDAR, which is almost like a digital elevation model type of imagery. Also, interestingly enough, in a lot of urban projects, we're seeing a lot of closed circuit TV cameras, CCTV, being utilized quite a bit, or even vehicle cameras, where you've got companies driving vehicles through streets, similar to something like Google Street View, and pulling data from there. So there are various forms of data collection in GIS, and we've kind of matured from that sole satellite imagery paradigm all the way to these other data sources, really. Cool. Nice. So yeah, so if you guys are interested in data science, there's actually a lot you can do with data analysis and transformation in GIS. So you can apply basic Boolean algebra to these massive raster data sets from the satellite imagery to be able to determine different things such as like land suitability, for instance. You can also use clustering algorithms, which are actually used quite a bit in the defense sector, to determine distinct entities on a map, for instance. So let's say you've got satellite imagery and it's too big to actually go in by the human eye and actually see if there are any discrepancies. You can use clustering algorithms to scan over those and determine if there's anything that doesn't quite, I guess, fit in or has its own spatial group, for instance. Similar to the raster transformations, we can use supervised learning algorithms for object recognition or different land classification. So you can select an area on a map that you want to classify, and then you can train this model on that area, and then you can basically end up classifying a massive amount of land just using a few samples. So that's how this whole data analysis and transformation, that's just like, I guess, part of how it works in GIS. If you want to play around with that, I'd recommend this product. Well, I wouldn't recommend it, but I'd suggest you look at this. Jupyter Notebooks, I think it's an open source product typically, but it's been extended to work with ESRI. And you can actually see your geospatial analysis in real time in this notebook format. So yeah, if any of this interests you, definitely give that a look. Cool. So now a bit more into like GIS development. This is the typical GIS application architecture. It's very similar to most web applications, or even just the client-server paradigm. You've got some relational database, and then you've got that database connected to by a REST server, following the REST protocols, and then that REST data is usually pushed over to the user client, whether that be on mobile, web, or desktop. Usually with geospatial information systems, we have this concept of tiling. So you have this map that you can kind of break into almost like a Cartesian axis, where you can kind of just slice it in pieces. And those pieces are usually tiles. And every time you interface with the user view, your geospatial REST server will give you the tiles that you've scrolled to on the fly. There's some interesting computer science behind how they cache this data as well, which I won't go into, but yeah, that's generally how it works. And more than just that base map, you also use this for different features. So when we talk about GIS, we're not just talking about the map, we're talking about the stuff that's overlain on top of the map. So at the top, we have, at the top of this diagram, we can see these open source solutions, GeoServer and Leaflet. And then at the bottom, we have the ESRI stack. So ArcGIS Enterprise and the ArcGIS API for JavaScript, both of which are pretty decent solutions to build, or starting points to build whichever application you're after, usually within a web application context. But there are also mobile solutions, such as the ArcGIS SDK for iOS and Android. Cool. So moving on, that was a bit of the, I guess, introduction to what GIS is. So I guess it would be worth introducing you guys to some GIS projects that I've been a part of recently, and walking you through, some case studies that should hopefully inspire you to go ahead and do your own GIS projects. Cool. So I guess let's get started. Sorry. Shout out. So this was the project that gave me the privilege of winning that Young Scholar of the Year award for Australia, where we got flown over to America. And this is a very interesting project. So this project is not just one web application, but it's actually designed to overhaul the paradigm of public community reporting. So instead of having community reporting follow this old monolithic process from a societal structure of trying to figure out who to get in touch with, and then your report going through this very, very long bureaucratic chain. Shout out was made to streamline that process using geospatial information systems. So it's a 4 application stack, really. So we have 4 apps in this. We've got a community reporting application. So let's say someone in the public has an issue, such as like graffiti or a fallen tree, that they can use this application to fill out a form and report it. We've got moderation, where the data gets moderated to make sure that the false reports are cleaned out or more data is added. Then you have a prioritization phase where you can prioritize the different community reports that come in. And then you've got task allocation to the government departments. So let's have a look at what you're able to achieve with GIS with this 4 application paradigm. Cool. So for data collection, this is built using this framework called Survey 123. It's an ESRI framework. And the idea is that there's this public facing application where a user can put in their data. So the type of observation, the date and time, the location, further details. And that data goes off to the servers. And then it enters this moderation panel. So within this moderation panel, you see a map overlain with these different issue types. And a moderator can go there based on the color of the issue and decide what, they can select these issues and figure out if there are any gaps in it, or potentially call the person that submitted the issue to make sure that, it's valid. Next, we go to this prioritization dashboard. So all of the moderated incidents come into here. And from here, they're prioritized, and you can kind of see how many recent incidents there were and what types of incidents happened. And then from there, you go to a task allocation dashboard. So the good thing about using, the reason I went with ESRI for this was like the integration is very good. Most government departments already have ESRI within them. So integration to their current systems would have been very easy. So task allocation basically takes those user groups and allocates these tasks out. Yeah, so that is shout out. I guess, do we have any questions in the chat? I don't think I can see that just yet. I'm gonna have a look. But yeah, any questions so far, just throw them in the chat. Cool, thank you. Let me just get on to slido.com. Log in. Oh, wait, sorry. just need to enter this event code. 359. Yeah, so if you have any questions, you can join at slido.com with the number 19359. Cool. So I'm just going to start off with a question from Liam. How is your team like in Shoutout? Did you work with full-time developers or thanks? So yeah, Shoutout was an interesting one. It was really a one developer team. It was myself. It was built over like a couple of months. And the fact that it was such a small development team is one of the reasons why I decided to go with the ESRI solution, because a lot of this stuff was configuration based. Of course, I had to build a few things out, but it was pretty achievable. Yeah, so I guess I had to make one of those decisions where was it a good idea to go with out of the box or build from scratch? Cool. I have an anonymous question. Where do I find these opportunities, and where can you find events that welcome students to participate in GIS? That's another very good question. It really depends where you're located, I guess. Maybe not so much during COVID, but if you're a student, I definitely check out your university for different GIS courses, and there are also quite a few GIS communities there. Another thing would be to actually look into the ESRI Young Scholar Award, the one that I did. I think that's a very good opportunity for students to have a project and work towards it, even if you're building out a project just for that award. Yeah, cool. So if that's all of the questions so far, let's move on. So RMAP. So this is the next case study that I wanted to talk about. This was a product that we built using for a hackathon back in November 2019, before all of this COVID stuff. It was a very interesting product. This was designed to empower indigenous communities to, I guess, share their knowledge and preserve their knowledge. So before, I guess, going in deeper, let's just talk about the general objectives of this project. So yeah, there's a lot of very valuable indigenous knowledge out there. And I feel like, and many people feel like this knowledge is almost going extinct. We're entering a phase in this 21st century where you've got like a lot of urbanization, and a lot of people are moving from these rural areas to cities, and all of this very important societal and environmental knowledge is getting lost. And just an example, some of this knowledge is currently being used to prevent bushfires, for instance. The indigenous nation in Australia were very, very good with land management. So a lot of this knowledge is going to waste, both within the communities, and people outside the communities aren't able to harness this. So the objective with RMAP was to empower indigenous communities to share knowledge in a respectful, controlled, and private way. So when it comes to sharing indigenous knowledge, it's actually quite a heated topic, because indigenous communities, of course, they'd want to keep the intellectual property to their knowledge, and they'd want their knowledge to stay with them because there's a lot of distrust in the system. So the objective here was to empower those communities to decide who they share their knowledge with, but also allow them to preserve the knowledge within their own communities. And the third main objective here was to utilize indigenous storytelling culture through land and find an equivalence within software. So you've got these indigenous communities that predominantly transfer knowledge through storytelling. And most of the storytelling is done with like geographical references. So you'd have creeks with stories associated with them. You would have different stories associated with different like communities in those areas. So it became very evident that for something like this to work, we really needed to go at this with the geospatial context. So yeah, I'll just walk you through a few of the things we built out. We tried to integrate satellite imagery with user collected data. So this is an example of where we were using satellite imagery. So we thought that the scientific scope of knowledge could augment the indigenous scope of knowledge. So here, for instance, we found scientific data on endangered plant species in Australia. And we had a pretty decent way of integrating this into the application. So we could store, I guess, data on flora. But then we also integrated that in with community data collection. So let's say the community knew about other plant species that may have special benefits or that are edible. We were able to collect that data from communities as well. By the way, my apologies for the user interface. This was, as you guys must know, hackathons can be pretty intense. So our UI guy was off that day. But yeah, that's the general idea. One of the most important things about this project was to take privacy seriously. So even with things like plants, it's very important to respect privacy, and it's very multifaceted within indigenous contexts. So we couldn't just go for the usual privacy paradigm of groups, because even within groups, you have subgroups, and even within subgroups, you have like sectors where you can only share knowledge, for instance, with men or women or others. So there's women's business and there's men's business within Australian Indigenous culture, and I'm sure that's the same around the world. So there were quite a few things that we had to take into account. Furthermore, even with future iterations of this project, we were contemplating using something along the lines of blockchain technology to be able to verify the source of all of this data. Of course, we can't go before the data has been entered into the system, but it's just something to ease that distrust that exists within the societal structure. So yeah, those were two case studies of mine using GIS within web application or general application development. I also went through a bit of analysis. Unfortunately, due to our time constraints, I couldn't really get into depth, but I wanted to give a relatively good overview of this. So yeah, I just got a question in asking how GIS data is collected, whether it's through IoT. And just jumping back to the slides, that's exactly what I'm about to go through. So your GIS, you can get started with your own GIS analysis using different data sources of freely available data. I don't know if you guys are familiar with USGS, but they usually have this satellite imagery called Landsat imagery, and I believe some of that is public. So if you wanted to get started with like the raster analysis, the stuff that I went through where you can use those satellite imagery to cluster stuff or use supervised learning algorithms to classify data, I'd check out USGS. On top of that, if you're after vector data, so that's the type of distinct data like GPS locations of flora or fauna, there's quite a lot of data like that on the Geoscience Australia website. So I definitely recommend you check that out. In addition to that, if you're interested in more societal data in nature, I know that Victoria's state government has a Department of Transport open data service, also through ESRI coincidentally. But I know a lot of state governments have their own open data portals that you can check out for even more data. So there is, honestly, the most fascinating GIS analysis actually comes from this publicly available data. So I would really recommend you guys check these data sources out, and even if you find more ones, feel free to share them within the socials. There's honestly so much good data out there. It's honestly worth having a look at. Cool. So I guess thank you all for your time. I'm ready to take any questions if there are any. I see a few have popped in. So yeah, feel free to throw your questions into the Slido, I believe, slido.com. and I'll get to them as I can. Cool. So how is GIS data collected, IoT? So yes, there are so many data collection sources like I outlined in that slide. If we just go back to it really quick. Yeah, data collection. So there are honestly so many different types of GIS data, but yes, IoT is actually one of the most common methods of collecting GIS data with relatively modern GIS, I guess, research or even GIS projects. I don't know if you guys have heard of smart cities. Quite a lot of smart cities are using GIS data. I mean, are generating GIS data through IoT devices. And I certainly think once 5G becomes a bit more widespread, we're going to see a lot more of that within our industry. Cool. Next question, I guess. Did I talk to indigenous people while developing the RMAP application? If so, what did they think of this project? So yes, with RMAP, we had, during the hackathon, we had an indigenous representative with us at the time, which was very good. He offered very, very good insights into it because these are very culturally, I guess, sensitive areas where we really need to be very respectful and acknowledge that even if we have a really, really cool algorithmic idea or a really nice way to create a view, that's probably not the right way to do it within the context and the societal bounds that are given to us. So we definitely did have an indigenous mentor for that project. We are planning on continuing that project in the relative future. And for that, we've also been put in touch with a few indigenous communities. So yeah, it's definitely one of the most important parts with that project specifically. Cool. I guess if there are no more questions, thank you all for your time. It was a pleasure. If you have any questions, feel free to contact me at the email that I'll just, I guess, put in the comments after this. Probably should have included it on my slides. But yeah, thank you for your time.
Thank you so much for coming, everyone. Here are the links for our Facebook, Meetup, and Slack channel.